Hi, welcome to my channel. I'll be making a series of videos as it is my passion to share information and knowledge about the data and tech industry. So in this video, I'll be touching on the topic of fundamentals of Python. So if you really like this channel, definitely appreciate your support by liking this video and subscribing to this channel. So let's first start off, what is Python? Python is a flexible general programming language known for its readability and its easy of use. Some of its characteristics are high-level language, which means it's not really tied to the OS. It's not a low-level language such as the assembler or even the C. It's a cross-platform, which means you can write programs that will run on different operating systems, different CPU architectures, and even different kind of devices. It includes an extensive standard library, which means you don't really need to write a lot of code on your own. You can reuse the code from the library that has already a lot of functions and objects that are ready to use. It's pretty flexible, which means you can easily adapt this to your own needs. It has high readability, which means when you access some source code written in Python, it is easy to understand, easy to read, even if you're new to the language. And finally, it has a large community. That also means you'll find a lot of answers and a lot of people will help you with a code and documentation all around the web. Let's see some short history about the language, shall we? The language was created by Guido van Rossum in 1989, and it was inspired by another language known as ABC language. So it's not really a new language. It's not so well compared with other languages such as C, C++, but also it's not so modern compared with Java, JavaScript, Kotlin, or Swift. Guido is actually the principal author and he is still working in Python. It's actually a foundation right now. And his central role in deciding the direction of the Python is actually reflected by the title given to him by the Python community, also known as the Benevolent Dictator for Life. So Python is not an actual implementation. It's an abstract language reference. By the way, it's open source, and anyone can create implementation from it. So actually, you can create your own Python if you want to. But most of the time, we are talking about one specific implementation, and that real name is Cython. This is the first and most common and also the de facto standard implementation for Python that is written in C and authored by the principal author himself, Guido van Rossum. So from now on, we'll be talking about this in other videos, okay, and also in the community about Python. But bear in mind, we are usually talking about Cython, okay, the most common implementation of the language reference. There are other implementations as well, such as Jython, that is actually using the same language reference, but compiles into a Java virtual machine. You also can run it anywhere that you run Java. IronPython is a .NET implementation. PyPy is another one that is actually more performant than the C Python. MicroPython is actually more for microcontrollers, so not computers or phones. Okay, so microcontrollers are those like in the IoT, Internet of Things. And Cython, that's a Python for C language. In terms of the version, there are three major versions that we need to understand. We have the first stable version that actually appeared in 1994. That was the original version created by the principal author himself. Then we ended up with version 2.0. That is currently today the most famous version out there that actually appeared with the new millennium. So in 2000, and it does, for example, Unicode support. So emojis, for example, and the object oriented programming, which is OOP. And also Python, in this case, moved from a Gradle project to a community process that will evolve and update the language over time. And finally, we have 3.0 that has appeared in 2008. That is the major last change that rectified fundamental design flaws in the language created by Gradle originally. But this version it breaks the backward compatibility, so code written in Python 3.0 will no longer be compatible with Python 2.0. So if you have code written in 2.0, it's not going to work for 3.0. And what can we do with Python? We can do web development, mostly on the back end, but also on the front end. But however, it's mostly targeting the back end. You can do web services, accessing database, performing data analysis, and visualization. If you're working with Python, if you're working with data, Python is definitely your language. Machine learning, artificial intelligence is typically done with Python. Scientific computing, as you can see, everything related to data science is actually directly connected with Python. Automation and scripting, in this umbrella, you can do the scripting for anything. It can be network automation, security automation, testing automation, and even more. Even today, Microsoft Excel supports the ability to write the scripts within a spreadsheet directly in Python. And of course, much more. You can work with blockchain development. You can work with security. So learning Python is a good idea because it will lead you to access new opportunities and in different markets. Now let's get to the fundamentals of the language. Talking about the lexical structure, this is a set of rules that govern how characters are grouped into tokens and organized to form valid Python code. And by the characters, I'm talking about the letters that you write in your Python code. So characters will be grouped into tokens, and then that will generate valid Python source code. In this case, the structure includes the lexicon. The lexicon is just a collection of reserved words, keywords, and identifiers used within Python programming. These lexicons are converted into tokens. That is kind of an internal name, and those tokens are the atomic code elements of the language. And the parser, that is a tool that will read your code, will create something known as an abstract syntax tree. This is a very internal, very low level on how Python works. But the idea is that based on what you're writing, a tree structure will actually be generated by this parser and will define what your code will do. The vocabulary, the lexicon, is a mix of reserved words. For example, the word class, import, if, while, and def, which is known as define, so special names for Python. This include identifiers. Those are the names that we give to our functions, to our variables, and to our components. The lexicon also include comments, and these are just text that is going to be ignored by the parser. And we typically use it to add context or explanation to whoever is reading our code. That can also be ourselves in the future. The lexicon also include literals. Literals are just a notion to represent a value. It can be a numeric value, a text-based value, a Boolean value. Operators are also part of the lexicon. These are symbols to perform an action such as assigning the value or making a division between two numbers. And finally, delimiters. There are just one or more characters that are separating the rest of the characters in the group. For example, the parentheses. All these elements are part of a Python lexicon. After the lexicon, we have the syntax. This is the set of rules and convention that dictate the correct structure and arrangement of code such as the keywords, operators, punctuation, expression that will form that will form valid and meaningful Python programs. So there are a couple of rules, and using those rules is crucial for making sure that the code is syntactically correct and also readable. Violations of these rules can lead to syntax error, and then your code will not work. So errors prevent the code from running as intended, and we will want to avoid that. Some of the syntax rules that are available are such as indentation. That has to do with spacing before writing the code on each line. Using the colon character on some special places, the white space that we use, so if you use it or not, okay, on some places can be a problem. Quotation marks, parentheses, or even the lack of end of statement is also part of a syntax rule. If you know from other programming language, maybe you have heard we end line with a semicolon. Well, that's not the case for Python. We don't end the statement, so that's part of the rule. So we have a rule saying that we shouldn't end the lines within a special character. Finally, we have semantics. That is the meaning or interpretation of the code. In this case, is how the code is executed and what it does. In this case, you'll depend on the variable assignments that you make, the function calls, the control flow, exception handling, input output, and making modules. All these topics will actually make up the semantics of your code. And when you read the code, you will understand, based on this characteristic, what the code is doing. And that's it for this video. If you like this presentation, be sure to like this video, share, and subscribe to this channel. Thank you for watching.